Hello everyone. Today we will start a new chapter, and in this chapter we will discuss about testing. So if you remember, in the previous chapter we have discussed in details about confidence interval. We have discussed about the confidence interval for mean and for proportion, and now in the chapter we will discuss about hypothesis testing. The learning goals of the module is as follows. So we will discuss about hypothesis test that I have mentioned earlier, and we will see what is the difference between null hypothesis and alternative hypothesis, and then we will also discuss about left tail test, right tail test, and two tail test, and then we will see how we can calculate p-value, and we will also briefly discuss about errors and power of a test. So let's first start with the discussion of null hypothesis and alternative hypothesis. So what is a null hypothesis? So in null hypothesis, basically we assume something to be true or something equal to something. And on the other hand, in the alternative hypothesis, we claim something opposite to the null hypothesis. So if, like, say in the null hypothesis, if we claim like something is true or something is equal to something, then in the alternative hypothesis we claim something opposite to that. That means something is not true or something is not equal to something, right? Something. I think now it is clear to all of you like what do we basically mean by null hypothesis and alternative hypothesis. But in the following slide I will clarify that with an example. Say a manufactured company manufactures some car, and they claim that the mileage of the car is 57 mile per gallon. Therefore, in the null hypothesis we assume that that is true. That means the mu equal to 57, since we have assumed that the claim of the manufactured company is true, right? So that we have discussed about our null hypothesis. Like on the null hypothesis we assume that something is true. Therefore here the population parameter mu equal to 57, right? And all the alternative hypothesis, we believe like it might not be true, so we want to test whether it is basically less than 57 mile per gallon, right? So here it is a left tail test, since here we are comparing mu less than 57, right? So it is a left tail test. So for a left tail test, here the parameter mu is the parameter, right? Mu is the population parameter less than some claimed value. Here you can see the claim value of the manufacturer was 57. So here the population parameter is less than the claim value, and we call this test a left tail test. I think it is now clear to all of you like what do we mean by hypothesis, null hypothesis and alternative hypothesis, and what is a left tail test. We'll discuss about the right tail test and the two tail test later. Let's now discuss about this problem. So here a school has invented some new teaching methods, and they believe it has raised the average test score to 75. And in fact, we also believe that this new method could increase the test score to more than 75. So in that case, then what is our null hypothesis? Our null hypothesis is here the mu equal to our mu equal to the claim value, and the claim value is 75. And here we in fact believe that the new method could increase the test score. Therefore we are testing mu greater than 75. So whether it is a right tail test or left tail test, it basically depend on like how you frame the question. Even for the same even for the same problem, you can in fact test right tail test or left tail test. So it basically depends on how you frame the question. So here we are in fact believe that the new method could increase the test score. Therefore here our alternative test is mu greater than 75. So here the mu is our population parameter, and it's greater than some claim value. Therefore it is a right tail test, right? So remember, for a left tail test we use a less than value here, and for a right tail test the we compare it with greater than sign, right? Yeah, our population parameter greater than some value, and for a left tail test our population parameter less than some value, and in that case we have greater than some value. Therefore it is a right tail test, right? Now for the same problem, we say want to test whether the test score in fact is different from 75. So here the claim value was the test score is 75, and we just want to test whether the test score is different from 75. Therefore in the null hypothesis would be the same for all the cases, right? So in the null hypothesis we assume that something is equal to something, therefore here mu equal to 75. And in the alternative hypothesis, now we just want to test whether mu is different from 75, right? So here mu is our population parameter and we want to test whether it is different from 75. That means it could be either less than or it could be either greater than, right? So here what we have then, here we have the population parameter. So mu is our population parameter, not equal, that means different from the claim value, right? So therefore it is a two-tail test because it combines both the left tail test and the right tail test. I think now it is clear to all of you, like what is null hypothesis, what is alternative hypothesis, and what is a left tail test, what is a right tail test, and what is a two tail test. So to summarize, for a left tail test, we test on the alternative hypothesis or population parameter less than some claim value, and for a right tail test we test whether our population parameter greater than some claim value, and for a two tail test we test whether our population parameter is different from the claim value, right? So this is basically the difference in between like the left tail test, right tail test, and two tail test. I think now it is clear to all of you, like what do you mean by left tail test, right tail test, and two tail test. Let's discuss about the main idea of a hypothesis test. So for a hypothesis test, we start with a claim, right? We start with a claim about our population parameter, so which is our null hypothesis. Then we have an opposing claim, which is the alternative hypothesis, and then we collect the sample data. Then we calculate how likely the sample result is if the claim is true. So based on the sample, we calculate how likely the result from the sample is if the claim is true. And then we use the probability to make a decision about the claim, whether the claim is true or false. And to use the probability, we need a test statistics. We'll discuss that later. And by using this test statistics, we calculate the probability and we compare this probability value with something with another value, and we name that as level of significance. We will see later what do you mean by level of significance. And let me discuss the steps again. So first we start with a claim for the population parameter, which is our null hypothesis, then an opposing claim, which is alternative hypothesis, then we collect sample data, then we calculate how likely the sample result is when the claim is true, and then we use probability to make some decision about our claim. And to do that, we need a test statistics. We'll discuss that later. And we using this test statistics, we calculate some probability and compare with another value, and this value is known as level of significance. We will also discuss that later. So now one thing is very important to remember is that here for the hypothesis testing, we are not proving anything. So that's not a mathematical proof. Rather, here we look for the evidence based on the sample. So here we look for the evidence for something or against something based on the sample data. So it is not a proof, right? So let's now look into this problem. So for a particular breed of dog, the vets suspect that its heartbeat may be slowing down. So here for this particular breed of dog, the normal heart rate is typically 115 bp per minute. And from the recent sample, from the recent observations, we have considered 6 sample, and from the 6 sample, the mean that the sample mean is 105 bp per minute with a standard deviation 12 bp per minute, right? So these are the information that we have. So here the population parameter is 115, and based on the sample result, and this is our sample result. So we have our sample size is 6 here, and the sample mean is 105 with a standard deviation 12 bp per minute, right? So this is the information that we have. Now for this we will discuss like what is our null hypothesis, what is our alternative hypothesis, and how we can calculate p-value. So here for the population parameter value was 115. So under the null hypothesis, we assume that nothing has changed. That means the heart rate for the breed of dog is still like on 15 bp per minute, right? And on the alternative hypothesis, the bait concern is like the heart rate is slowing down. That means probably the value of the population parameter has reduced. That means here the parameter value less than 115 or not, that we are testing, right? This slide is very important, so let me discuss about this slide in details. So here our population parameter value was 115, right? Our population parameter value was 115, and we had a sample of size 6, and from this sample our calculated sample mean was 105, and we want to test how compatible our sample result is when the true population parameter value is 115, right? Then what is the chance that we can still get a sample with sample mean 105 if the true population parameter value is 115, right? So how then we'll be doing that? So we need to calculate the probability of observing a sample mean less than or equal to 105 if the true population parameter value is 115, right? And if the probability of observing the sample mean less than or equal to 105, assuming the population parameter value is equal to 115, and if this probability is very small, then what does that mean? That means we have evidence against the null hypothesis, because here we are assuming mu equal to 115, which is our null hypothesis, right? So that was our null hypothesis. Now we are calculating the probability of observing x bar, which is the sample mean, less than or equal to 115, assuming our null hypothesis is true, right? And if this probability is small, that means we have evidence against the null hypothesis. That means it might not be true. Our assumption about the null hypothesis might not be true, right? Since this probability is small. So we call that like we have enough evidence against the null hypothesis, right? I think now it is clear to all of you about the concept or idea behind the test of hypothesis. So now let's see how we can calculate the value for the test statistic. So this is the formula for calculating the value for the test statistic. So here this is x bar, which is sample mean. This is population parameter value, which is mu, right? And this is the standard deviation, which is standard deviation for the sample mean, which is sigma over square root of n, right? So for the sample mean, we know our sample mean was 105. Our population parameter value under the null hypothesis was 115, and our standard deviation was 12, and our sample size was 6, right? And finally we get this value very close to negative 2.04. So what does that mean? That means, like our mean value, sample mean value 105 is negative, is 2.05 standard deviation below the hypothesized value. So that means here, like this value, this sample mean is 2.04 standard deviation below this population parameter value, right? And now based on this value, we'll be calculating the probability, which I'll be discussing in the following slide. So here our test statistics value was negative 2.04. Now we need to calculate the probability, and we will be calculating the probability that was a left tail test, right? And our g value is also negative. So if the test statistic value is negative, then it in fact should be a left tail test, right? So here then for a left tail test, we will be calculating the probability that what is the chance that G value would be less than or equal to negative 2.04, right? And how we can calculate this probability? This is a left tail G table, and this is just the part of the table. This is not the full table. So our G score was negative 2.04. So this is negative 2 and this is 0.04. So this is the value, right? So this is the probability value. And what is this value? This is 0.02068, so which is basically very close to 0.0207, right? We can round that to 0.0207, right? So this is the probability. So it is about 2%, right? So it is about 2%. So that was and this is the probability. And remember, so this probability value that we calculate for the test of hypothesis is basically known as p-value. So p-value is also a probability, right? So what is this probability? This is the probability of observing a value less than or equal to 105 if the population parameter value is like 115, right? And in terms of G score, so this is the probability, this area, right? This area is like 0.0207, so about 2%. This area is about 2%, right? I think now it is clear to all of you like how we can calculate this probability, which is basically terms as p-value for hypothesis test, right? So we have seen in the previous slide like how we can calculate the p-value, and our p-value was about 2%. And what does that mean? That means there is only 2% chance of observing a sample mean 105 or less than that if the true population parameter value is 115. So what does that mean? That means there is a very smaller chance of observing a value of observing a sample mean of 105, right? 105 if the true heart rate was 115. And that means we have strong evidence that the heart rate of the heart rate of the breed of the dog is in fact not 115, right? So we are rejecting the null hypothesis. We have enough evidence to reject the null hypothesis, right? And what does that mean? That means we have enough evidence for the alternative hypothesis. And what was our alternative hypothesis? In the alternative hypothesis, that was a left tail test, right? Our population parameter less than 115. That was our alternative hypothesis, right? That means we are providing strong evidence that the heart rate of this particular variety of dog has indeed probably slowed down, right? So let me clarify again. So what is the p-value? So p-value is basically tell us how likely our sample result is if the null hypothesis is true, right? And what does a smaller value for p-value indicates? That means like we have a strong evidence against the null hypothesis. That means we have a strong, in other words, like we have strong evidence for the alternative hypothesis, right? So if we have a strong evidence against the null hypothesis, that is similar to saying like we have a strong evidence for the alternative hypothesis, right? I think now it is clear to all of you like what do you mean by p-value. Let us briefly discuss about the errors and power of a test. So there are two errors associated with the hypothesis test. One is type 1 error, so which is basically rejecting the null hypothesis when the null hypothesis is true. So if we reject the null hypothesis when the null hypothesis is true, so we are committing some error, right? And this error is known as type 1 error, and we also call that level of significance, and we denote it as alpha. So our type 1 error is basically known as level of significance, and we denote that by alpha. And what is our type 1 error? Probability of rejecting the null hypothesis when the null hypothesis is true. And there is another type of error that is also possible, failing to reject null when the null is false. So if the null is false and if you fail to reject that, so that is also a type of error, right? And we call this error type 2 error. We call this error type 2 error. And what is the power of the test? So 1 minus the type 2 error, that means the type 2 error is basically denoted as beta. So, and the power of a test is 1 minus beta, that means 1 minus the type 2 error, right? I think if you just remember, like the type 1 error is the level of significance, which is alpha. I think that is good enough for this class. And for test of hypothesis, we basically compare our probability value, compare our p-value with this level of significance, to justify whether we'll accept the null or reject the null. We will discuss that later. Yeah, but remember that. So this is our type 1 error, and which is denoted as level of significance, right? So how we make decision about a test? So we compare our p-value with the level of significance alpha. So we calculate the p-value. We have discussed like how we can calculate this p-value, and then we compare our p-value with the level of significance alpha, and we basically give a value for the alpha. And if the p-value is less than or equal to alpha, then we reject the null hypothesis. And we basically tell we have enough evidence to reject the null hypothesis, right? And if the p-value is greater than alpha, that means we do not have enough evidence to reject the null hypothesis, right? And this is the way, and then using this information we interpret our result. So let me clarify again. We calculate the p-value from using our test statistics, then we compare that with alpha. If the p-value is less than or equal to alpha, then we reject the null hypothesis, and we say like we have enough evidence to reject the null hypothesis. And if the p-value is greater than alpha, then we say we do not have enough evidence to reject the null, right? I think now it is clear to all of you like how we use alpha and compare that with the p-value and then make decision about the hypothesis test, right? Let's discuss briefly what does different p-value basically tell us. So if the p-value is very small, like say 0.001, then we have very strong evidence against the null hypothesis. And if the p-value is 0.05, then we have moderate evidence against the null. If the p-value is 0.10, then we have weak evidence against the null. And if the p-value is large, like say 0.50, that means we have no evidence against the null, right? So usually we, for the p-value, usually compare with like 0.05 and 0.01, and sometimes like with 0.10. So usually with 1%. So that is even not 1%, that is basically 0.1%, right? And yeah, this is 5%, this is 10%. So yeah, so these are some of the p-value and what does that indicates against the null hypothesis, right? So to summarize what we have learned today, so we have discussed in details about the framework of the hypothesis test, and then we have seen how we can calculate the p-value using the test statistics. And we have also discussed about the two type of error, type 1 error and type 2 error, and power of a test. And another important thing is like the hypothesis test doesn't prove anything, that just give us the evidence for the null hypothesis or against the null hypothesis, right? So we based on our hypothesis test, we can just tell whether we have enough evidence to reject the null or we do not have enough evidence to null hypothesis, right? It is not a mathematical proof.